welcome. Thank you for coming. My name is Freriks. Pfeiferová is going to join us in a few minutes. So we've been running a lot of experiments at the network company with AI. I assume, like everyone here, and we've been trying to generate some code with AI. We did some refactorings, code-based search, debugging, documentation, and we've been trying to find out the way how to do it like the best possible. There's one thing that actually stood out for us in matter of giving this quality assurance, and it's testing. We had mixed results everywhere, but testing is actually where we leaned in. So be honest, quick raise of hands. Who has an AI coding agent open on their computer today? 1, 2, 3, 4, 5. Okay, thanks. And who trusts that it didn't quietly break something yesterday or the day before? Right, so maybe, okay. So the common thing is that we have this mistrust, right? And the gap between the first raised hands and the second is the whole problem. And actually, that's what we are going to talk about here. So, Greenfield. AI is the win. The weekend, we build the MVP. It works. We ship. We forget. But come back next month, or maybe even next Monday. With AI, we move much faster. But agents lose context across sessions. We have more changes, faster iterations, less memory stored, and regressions creep in. It changes things without knowing why they mattered. The business decisions made prior our coding sessions. It doesn't know why that constant or that order was deliberate, and bugs accumulate. It looks fine locally, then ships broken. And code base gets messy faster. And we actually think about AI as an enthusiastic junior with amnesia and manager's confidence. Or like in Rick and Morty's Mr. Meeseeks. AI is great. None of this talk is anti-AI. We actually love to use it as a tool. So we tell the AI the rules. We wrote Claude MD documents. We have shared memory. We write skills to help us and to help actually Claude, because that's our agent we use, the AI we use. We guide it in a way that feels efficient for us. Check what it did. A test. It fails loudly when the result is wrong. And that's the one thing that it can't slip past. A prompt is a hope, a test is a proof. So, coverage is an unlock. This is the test pyramid we learned. Lots of unit tests on the bottom, fewer integration tests, a thin layer of end-to-end on top. And it's built around one thing, and it's coverage, code coverage. Now watch what happens with AI. It refactors the code, then sometimes by its decision, it goes to unit tests and refactors those tests as well, just to see them passing and just to see the CI green. The PR ships and nothing is actually locked. And you kept the shape AI wanted, not the behavior you wanted. And this is kind of our thesis, that the code is the artifact and the business agreement is the source of truth. And that's the thing we actually need to lock. If there's something you should remember from this talk, it's actually this thesis. A test of satisfied business logic outweighs any test of technical details that can change without changing the business logic. So we inverted the pyramid. The white part moves to the top. Log the behavior. You can do this end-to-end test. That's totally fine. However, in other use cases, we had to catch regressions quickly, and it was much efficient to find another way how to actually lock it. But it might work for other use cases. So lock the behavior, the whole app. Unit tests don't go away. If you really care about some algorithms that needs to be locked, totally fine, and it works. So how do we actually do it? We created one big unit test. And what I mean by that, we lock the whole app in one huge unit. So you treat the whole app one big unit test. Pump the real app, real screens, real navigation, one test. And assert what actually gets. It's a one test and the whole flow. So what does it take? Imagine this. A user edits offline, then comes back online. The server must see those actions in the order the user made them. Quite a regular requirement. Sounds simple. Behavior lives between the state management. In our case, let's say for the dummy purposes, we have a block. So it stays between the state management, the offline queue, and the network. No single piece sees the whole thing. So this is exactly where a bug could hide. To lock it, you can't just write a bunch of unit tests. You need this. You have your real app in the middle with all these real blocks, real navigation, real widgets. And you have fakes around. So those fakes are at every seam where the app touches the outside world. The network, storage, time, Firebase, for example, connectivity, IOs. Everything inside is real. We only fake the edges. So this is already investment to the system. It's not just a test, not a framework. A small harness you invest in once. And every mobile app has these same edges or similar. So this isn't just a Flutter trick. As an example, what a test looks like. So we built this harness. We're going to talk about it soon, but what actually is hidden under this. The user logs in as Alice. Let me help myself with mouse, with the pointer. Yeah. User taps in and log in as Alice. For our dummy purposes, it's just a button. We pump the frame. Here we assert that this call has been called, and we complete it with a JSON. That's agreement between us and the backend that this stored JSON, that's something what we expect. This way we also test the parsing from JSON to Dart. Then we again pump the frame, and we accept that in session the movie appears. Again, the user taps, goes to the detail, and again there's assert of this API call being called, and JSON that it returns. Pump and settle, and there's expectation to see a date. In the end of this, we can also do golden. We can put their expect later, expect golden, and we can generate also a nice image of what the user can see. So the test harness, as it was in the beginning, is a wrapper around every test. The tester to drive the UI is this one. The app handle for the fakes, and the HTTP client for the exposure. Setup builds the fakes and wires them into the real app. Is right here. We're gonna get to it. Here we start the flick list app. It's a dummy app for the purpose of the presentation. Exactly what it's called in production. And here's the body of the test. And assert no pending API calls. Totally optional, but I just like to have it there, that there's no pending calls. So how the fakes get in? 3 steps. First, we build the fakes one per scene, right? Then we register them, as seen here. Then we call setup modules. We chose modular architecture for the app, so we set it up over there, and it's also the method being called in production, and we return the app. Now, this is the freedom half. Lock sets you implementation free. Same whole app test you just saw. Now a change request comes in. Migrates the movie list from block to report. Yeah, it's a weird change request. Anyway, AI does exactly what you've been asked or what you asked the AI to do. Wires up riverpod, rewrites the whole state layer. It builds CI is green, and test. We never touched the test because in the test we didn't care about if it's a riverpod or a block. We cared about the business logic being locked, and it's still green. It still passes. Your code shape changed, the lock didn't. Another test. So here, real business rule, and the test name is the rule. The first line inside the test is a helper. It's this one. Sorry, pardon. This one. Login and open inception detail. If it happens that we stumbled on some common navigations or calls, we just wrap it for reusement. Here, we stop and assert that the device go offline. We do some queues, so tester tap, add to watch list, pump it, remove, change of the decision, assert no pending calls, of course, because the app is offline. We put the phone or device back to online, and we expect that HTTP calls are being called. So we call one, expect a single pending request, then we complete it, we call the other one, and so on. Now, get the order wrong, and the server keeps a movie. So that's the lock we made here. Same test, now a dummy change request. This offline queue code is messy, simplified. Reasonable, nobody is trying to break anything. AI simplifies by flipping one line. Instead of draining the oldest queued action first, it takes the newest first. So the remove now jumps ahead of the add. Delete before post, doesn't make sense. It compiles, and locally the watch list looks identical. Without the test, this would sail straight through, but the test catches it. Locally, watch list looks fine either way. The wire tells the truth, and the log translates it into a sentence. So let's run it. AI rewired the code. The log held. AI changed the behavior. The log coded. That's the whole idea. And you log the business rule, not the code shape. So once you invest into this harness once, it pays off. Takes time to actually invest in it, especially if your code base is already running for years. But once you invested in it, it's gonna be cheap. It also reads like a documentation. So yeah, it's a matter of investment. For full disclaimer, it won't log stuff you would expect from the operational system, like the dialogues, App Store, biometrics, etc. We test the Flutter app itself, actually, not other themes around. So that's maybe where you would like to use end-to-end test. Now look at what grows on this soil. Over to Itka. Right.
So, hello everybody. My name is Pfeiferová. I work as Flutter developer at NetLight. And today I will be talking about how to teach AI to document and test your mobile application. So, as Michal already mentioned, nowadays in the world of AI, it's quite difficult to keep AI agents or to stop them from writing our code because they just don't know the whole context of our mobile application and all the business rules. So I will be presenting a solution that could help with that issue that I actually developed for one of our clients. So the goal is to generate a high-level documentation which is like completely code and framework free. So it doesn't matter if your app is written in Flutter or Kotlin. This is just high-level documentation that should be stored in your repository, and anybody from your team, like product manager, new engineers, backend developers, designers, or testers, can access it and look what is going on in your app on a high level. And of course, it's also source of truth for AI agent that use it as well. And this whole documentation is also covered by the test, which is like the same behavior, but in executable form. So this is the diagram, how it actually looks. So at the beginning, we have some scenario in the application. So it's a user journey through the app. And based on that, there's a high-level documentation in human readable way, and also the tests that are just covering the documentation. And both of these should be kept in synchronization. And of course, I don't want to do it on my own, so AI agent will generate both of that for me. So I will demonstrate this on a very simple dummy app. So this is our starting point, and this is just set of action, simple user journey through the app. So at the beginning, we have a login page, and we say, okay, let's tap login. And app is opened, and we see a list of movies. Then we tap the first movie, the detail is opened. There's one action, it's to watch list the movie. So I do this, and I see it was edit. It was edit. Then I tap back, and then I tap the second tab on the watch list. I can see the edit movie is present there. Then I tap the movie again. I can see the detail, and that it was added to the watch list. Then I go back and tap delete action. So it's actually deleted from the watch list. So this is covering basically one module of the application, which could be called watch list, but I covered all the actions that can be done there. In reality, it would be probably much more complicated, but just for sake of simplicity, I will be showing it on this case. So this is actually input for my AI agent. So I just wrap it to a markdown file and pass it to the agent. And the task will be to generate test for that. But actually, this is very broad task. So I want to do some additional pre-setup for the agent so that it's as easy as possible for him. And he doesn't start at each time for scratch. So what pre-setup actually I need? So firstly, of course, every application has some backend. So I need to handle all the API calls. Actually, my goal is that if I have some tests, so whenever API is called, I just want to have some answer for it during the test. So what I did is that I just downloaded all the API surface from Postman or Swagger or whatever you have. And I created from the example responses fixtures, JSON fixtures in my test repository. And then I put all the responses to the map. And I feed my fake HTTP interceptor with that or fake HTTP client, whatever I have. Like just then during the test, my goal is that the test will never fail on the HTTP calls. And then I have additional pre-setup. So I already covered backend. And then I usually also have some local DB, secure storage, SQL DB, or shared preferences. I just keep the same structure, just run it in memory. And there's another communication with external plugins like Camera, Firebase, or maybe I have some external monitoring service like Crashlytics or Sentry. So all these services should be like pre-set up and mocked as well, so the test will not crash. So like that, I have isolated app from the outside world, and this is my final pre-setup for the AI agent. So then I will create a skill. The high-level instruction would be to create out of my list of actions in the markdown I had a runnable test. Then the instructions would be probably something like map each action to a widget test command, like tap or enter, just some interaction with UI, and use the code base for that, navigation tree. And use some documentation in Markdown, which could be called test conventions. And this Markdown will hold all these pre-setup I just described. And I want at every end of the action, at some checkpoint, to capture a reference screenshot for the golden test. So in the diagram, you can see the input is my list of actions, my flow. I pass it to the skill, and I want like high-level test and the golden screenshots. So let's see how the output can look like for our demo app. So here is the test. There is again the test harness. Inside is hidden all the pre-setup I don't care about, and skill doesn't care about it at all. As well, it just uses it. And I can see that for every, let's say, action, I have just 2 lines. The first one actually is the syntax of the widget testing. So, for example, for tapping a button, it's tester tap, and it finds some keys to search for the button. And then there is a line that takes the screenshots and generates the screenshots in the right. So like that, I cover my whole scenario by this test, which is like quite simple. And the whole test is running locally, not on any emulator, just, and also it's implementation free. And it's like with fake time, so it runs same fast as unit tests, for example. And as you can see, this high-level test checks only UI state and also that it didn't crash through the scenario. So maybe I want to also test what is going on in the background. So for that, I can either use my AI agent and like let him search the whole code base and look like what API calls are fired and what is the structure of my DB during the whole scenario. But actually my code base can be quite complex. I can have a lot of layers. Maybe it can be legacy code. So the AI agent could miss something. So I would prefer more deterministic way. And actually, I have a perfect tool for that. I have my test. I can just introduce something like a tracing mode of the test, which is just a feature that actually turns all of my fake HTTP clients and local DB into a tracing services, and it tracks or records all the API calls, all the interactions with these services through the scenario, and it records it at the end of every action. So the input is that just I run my test in a tracing mode with a tracing flag on, and the output would be some transcript, which just summarizes like API calls fired during every checkpoint and state of local DB. Now I can use this transcript, and I can actually generate documentation based on that, and I will use it AI, of course, for that as well. So I will generate a scale. High-level instruction can be turn the tracing transcript of the app flow to the documentation. So firstly, run the UI test in tracing mode, and then based on the transcript, create a high-level documentation, and it should of course follow some template or some instructions that can be stored in some markdown, and it's just individually defined by me how I want it to look like. So you can see that the input for the scale is the transcript, the test, and the list of actions. And the only output should be just high-level markdown of like description of what is going on through the scenario in human readable way. So when I run the scale, this is how the output can look like. So I have here again my app, and at the beginning, what the scale generated is prerequisites. So it is that users signed out and my local DB is empty. And of course, I have the golden screenshot. Let's move on. So now when I tap login, I can see that list of movies is open, but also my agent generated what's going on in the background. So I can see what endpoint was called and what data were returned, and there is also a structure of them. This whole is a markdown file. So actually everything you see is referenced in your repo. So the screenshot is actually a golden image you use, the test is using for comparisons. And also the JSON file is like JSON fixture in the test that test is using actually when it fakes the API call. Like that, I'm mapping the whole scenario. So when I open the detail, I can see that another endpoint was called. I can see the structure of the JSON that was returned. Then I tap that I want to add the movie to the watch list. And I can actually see that at this time, no endpoint was called and the data were stored only locally to shared database. I can see the structure of the data that were stored, so only the movie ID and the date of edition. Then I go back, I can see that nothing happens. I go to watch list, again, nothing happens. I tap the detail and I can see that the endpoint, detailed endpoint was fired again. So maybe I can see that there's some space for optimization. Maybe I can cache this. Then I go back and I delete the movie from the chat preferences. So I can see that now the entry is removed, which is correct. So this is like high level screen by screen documentation. And it lives in my markdown file. So this is something that anybody who is in the team can access. And without reading any code, he can see like what's going on high level in the app, and it's completely framework free. So this can be valid for also like native apps or whatever. At the beginning, you have a name of the flow, and then there is a reference to the existing text test that is covering it, and then you can just go through it and look what's happening. So once I have this, I can actually log down the test. the behavior of the app, if I agree with that, and like finalize my test. So I have here just the example for screen 4 where I'm adding my movie to the watch list. So this is the initial test that checks only UI. But right now I also know that I am adding some entry to a local DB. So I just put an citations for that to my test, and I log the behavior also in the background. So I added that no endpoints were called, and I also assert a structure of my local DB. And of course, I have again skill for that. I don't do it manually. So the skill goes through the whole test and add these assertions to every checkpoint. Again, according to some rules I have defined. So this is the whole pipeline, how I actually mapping the app. So at the beginning, I have in blue my input scenario, which is just a list of actions. I pass it to an agent, and it goes through the pipeline and uses the skills. So it creates the preliminary test, runs it in tracing mode and generate the goldens. Then based on that, it generates the documentation. Then there is some human review where I say, okay, I'm okay with that or not. And based on that, I finalize my test with all the assertions. It uses these skills I defined. And also I have a documentation how this whole stuff should be done. So there are some test conventions. For example, in testing Markdown, I have test conventions or the pre-setup, all the method wrappers that should be used for that. Then there's, for example, documentation structure Markdown, which is like a template of how the documentation should look like. And these skills are just set of instructions that are using this documentation. So right now, I showed you how to go through the happy path. But of course, something can go wrong through the user journey. So for example, the most common case is that you are offline or the server is unavailable, just some endpoint fails. It can be also that some external plugin fails like biometrics unavailable or whatever. So I maybe want to simulate in the test this as well. And this is actually much easier than in end-to-end tests that are running on real devices with some proxy because I would need to do additional setup. But for me, it's quite easy because I just see the failing initial condition and run the whole pipeline again. So let's look how it would look at our dummy app. So the example is endpoint failure. So if you look at the initial scenario, now I successfully logged in. I loaded the movies, but when I tapped the first movie, the data endpoint failed. I got status 500. I will do the mocks at the beginning. So I just say that the inception endpoint returns 500. Otherwise, everything works the same. And I run my pipeline and generate the flow documentation and the matching test. So this is how the documentation would look like. There is a rule in my documentation that if anything is the same as like previous screen, there is just reference for that. So in this scenario, the first two screens are identical to the happy path. So there's just reference for that. And the third screen actually looks different because something happened. So there's error dialog that says something went wrong and there's a retry action. Then you can go further and maybe like carry on with retry action, but just for sake of simplicity, I stopped here. So when I scaled this to the real app, what this can be actually useful for. So this is actually what I'm right now doing on one of my apps, and it's mapping it with this testing and documentation. So if you have maybe some complex app or there's a legacy code, maybe you want to document it on a high level and log the behavior. So then when you want to do some big refactor, like, I don't know, exchange or update of state management or something like that, you already have something that logs it with the tests. And these tests are running quite quickly, so you can input them to your CI pipeline and just run them before every pull request. Also, if you agree on the documentation structure, you can use it for introducing new features. So before you introduce a new feature, you can just define it with this documentation. And based on that, you have a skill, so we can generate a high-level test. And this is already some checks you have before you even start to implement something. And one last message, always invest to this first. Before you start to covering the whole application with a lot of low quality tests and documentation, it's really good to think about it first, like what structure fits you the best. Also to invest to the test structure, because it should be still clean code and well structured and readable. And this really pays off in future. And that's everything. Thank you.
Thank you. Thank you. Michal, please come to the stage. And let's move on the questions. So the first one, we will not start from the Slido. I will read the questions to you guys. And we saw that your thesis is based on logging business behavior, right? If I get it correctly.
Correct.
So how you can ensure that the agent itself doesn't tweak this, business behavior? Because it's just a matter of, one pull request.
Right. Well, we don't get the business agreement from the agent. We get it from the project manager or somebody else in this chain, or we define it with the rest of the office. So that's actually the agreement we do, and it's just up to us to assure the quality. That's our role. And if it wouldn't be, then what's our role in here? Why are we even coding?
Okay, thank you very much. Another question. I saw on the screenshot that a lot of the things within your test chain is mocked, right? You have a lot of mocked HTTP requests, etc., etc. How you ensure that this HTTP requests and things like or things that you mocked do not drift from the real actual backend things?
Right. Well, it's still the agreement between what we understand or understood from the backend team. We can use fakes or mocks. It's also up to the team and up to the decision made in the team. And basically, it's done on the agreement between the teams.
Okay, perfect. Now going to the questions from the crowd. What percentage of the business logic do you cover by the tests that you shown us? If you can answer this question.
Yeah. So honestly, this is in experimental mode so far. So I think it's like 60% right now of my app. But I think I can like finish it with full. I just didn't have time for that so far. But of course, the goal is to have 100%. But I don't really goal for have like 100% test coverage. I just really want to cover what's important for me and what's important for the team.
Yep. Michele?
So I had a client in the United States where actually I had 100% test coverage by this, and we didn't test. We almost didn't have any unit tests, but we did this kind of approach.
Mm-hmm. How much does it cost you to keep such a 100% coverage test suite up and running?
Right.
How much are these tests flaky, etc.?
Yeah, that's a good question. I would ask. I will put the question back. How much it costs you to break something by changing a code?
Yep.
Right.
So you simply see the benefit of keeping such a coverage, pretty satisfied.
Yeah, it definitely takes time to test the code, and then it's also up to us how to make our lives easier. So if you invest into that harness and you create this system, and you make it in a way that it reads naturally to the human, then it's quite easy to test.
And another question, what do you perceive in the single biggest bottleneck in AI development on your project? And what does it take, the most of the time? If you can start.
I think it's exactly what we just described. It's like locking the business logic somewhere so the AI agent can look at it and it doesn't get lost during the development. So actually, it takes time to cover the whole application with these tests and documentation, but I think it will pay off and it will exactly fix this bottleneck, we hope, or help with fixing it.
Before we jump on another question from our crowd, do you cover somewhere or track the actual AI agent spend? How much does it cost you on the AI agent side? I mean, like, how much do you pay to Anthropic or OpenAI or Microsoft / Copilot? Do you know?
Honestly, I don't have a track of this, but to be honest, I'm trying to it's an iteration, right? So we have this test harness that we still like working on, trying to make it better through each iteration, and I'm preparing to have it at detached from AI at all. Like so it reads like a documentation, and you don't need any documentation additional to that. Like it's a nice thing to have, but once. Hopefully it doesn't happen, but if it happens, that AI is will gonna be like super expensive, then we'll be fine to leave it. But hope it's not gonna happen because
yeah, we will see. That's a question that will matter for sure. There's one question which I am super interesting if you will be able to answer, because you said it's in experimental mode and it's more about optimization. So do you consider that some test might be skipped if you know that the underlying logic didn't change? So whether in your design is that possible? So if you can skip some of the tests because of the logic wasn't changed.
I think that if the business agreement was not changed, then the test should pass actually. So why would I skip it?
No, it was code change. If the not the business logic, if the code hasn't changed.
Then still, if it's just refactor, then the test should pass, right?
Okay.
Or
I believe so.
I mean, if some of my tests fails, I don't want to look why.